of a to the fifth. There is actually a sixth root in there. All right, so continuing to move on to some that are a little tricky, or things that I think just might trip you up a little bit. If you look at 25, that's the first time we see a negative exponent. Anytime you have a negative exponent, it's the same as putting that exponent in the bottom and making it a positive. So a negative exponent means you put it to the bottom. If it's in the bottom, you would put it to the top. So here we have 1 over the square root of 100. Anything to the 1/2 power is just a square root. So 1 over the square root of 100 would just be 1/10. Right? Not too bad. Let's see here. 27 is very similar to that. Let's do 29 through 33 and we'll be done. All right, so for 29, this is an example of like what I was talking about before. I was kind of getting ahead of myself. Our indexes are obviously not the same. That's a 3. This is a 2. So we can't combine these yet. But if we put them into exponential form, v to the 1/3 power times v to the 1/2 power, now we can add these. We're going to change this to sixths, and that will be 2. And that will be 3. So then when we add these together, that will be v to the 5/6 power. We change that back to radical form. That'll be the 6th root of v to the 5th. And that's our final answer. So we couldn't combine them before, but we made them into exponential form so that we can combine them, put them back into radical form. And there's no way we can simplify here because the 5 is smaller than the 6. Now, for number 31, these are the ones that always get people tripped up. So this is 4 to the 1st power. Again, we can't do anything with it yet because we haven't put it into exponential form. So in the bottom, that's going to be 4 to the 1/3 power. Now, if you think about this, think about this as variables. That's 4 to the 1st power, and this is 4 to the 1/3 power. So we can subtract those, and that will give us, if 1, we change it to 3/3, that will give us 4 to the 2/3 power. We can still combine them because that was 4 to the 1st, which is 3/3. We subtract 1/3. So then we will change that from exponential form to radical form, right? So that will just be the cube root of 16. And granted, we had 2 as our exponent here, so you may think that it's completely simplified, but once we multiply that out, 16 will give us 4 and 4 and 4 2s. Now it takes 3 to pop one out, so we're going to actually be able to pop out a 2 and leave a 2 on the inside. That will be our final answer here. All right, and then lastly, sometimes you can simplify it out with exponential form instead of radical form. I'll show you both ways to show you that it works, okay? So with the form that you already know how to use, we would break up 10 into 8 and 2 because it's simplified, right? Or because it needs to be a multiple of 4. So 8 divided by 4 would leave us with x squared on the outside, 4th roots of x squared on the inside, right? And we will be completely done. So, right, 8 and 2, 4, yeah. So then if we decided to change this to exponential form, we could do x, our index is a 4, so that would be our denominator, and 10 would be up top, right? So then we can simplify 10/4 and just make it 5/2. Now, from there, 5/2 we can change back into 5/2 we can change back into radical form, and that would be the square root of x to the 5th. All right, so from there, x to the 5th, we would simplify that out and make it x to the 4th, x to the 1st. That will be x squared with the square root of x on the inside. Now, you may be saying, Mr. White, those are not the same problems. You've got a 4th root of x squared, and you've got a square root of x to the 1st. What the heck? Yes, and I will take either one of these answers. If you plug in a number for x and you type in both of these, you will get the same answer because if you take this fourth root of x squared and change that into radical form again, you will get 2/4, which could simplify out to 1/2, which will go back to a square root of x. So either one of these is perfectly acceptable. A lot of times, especially in the final exams and stuff like that, which you don't need to worry about now, but just in the future, if you're ever on a multiple choice question and they give you something like x squared to the 4, or you work out your problem and you get something like this, and then they give you x squared to the square root of x, you can kind of see how the 2 and the 4 will simplify, right? So just kind of, I'm putting that out there to keep an eye out for it, and show you that we can do it both ways. Technically, if you put it into exponential form to simplify, then you will always go immediately to the simplified answer. You will not have a fourth square root of x squared or anything like that. But I want you to understand that there is multiple ways to do this, and I'm perfectly fine if you give me this as a final answer. I just want you to see that there are